All right. You guys ready to get started? Thanks for coming. Thanks for showing up. Appreciate it. So we're here today to talk about what can you do with on-demand networking and the AWS Cloud. And it's kind of the emphasis to start this is on the you part of it. We've got a media and entertainment example, a use case that we're going to go through in a little bit with Brad Cheney from Fox Sports, who's the VP of Field Ops, and Evan Staton, who's the Senior Principal Architect for M&E at AWS. But we really want you guys to kind of take away, like, what could you do with any industry you're in, insurance, finance, whatever it might be. Think about what you guys can do with on-demand networking, which we'll talk a little bit about, and the AWS Cloud. So a little bit on me, I'm Ryan Cordy, I'm the Senior Director of Product at Lumen. Lumen is also, you guys may know some other names if you're in the media and entertainment space, the Vivix name. We've been in the broadcast, that's how Brad, Evan, and I know each other through a lot of the Vivix entities, but we're also CenturyLink in the past, but we've renamed to Lumen. So, global fiber backbone, a lot of assets that connect a lot of things together. So to jump in and get started, quick agenda, we'll talk a little bit about what is on-demand networking. Maybe that's a term you guys know, maybe it's something you don't know. I want to talk about what Fox, AWS, and Lumen did together for a baseball game, a Major League Baseball game. We'll talk about some of the impacts of kind of the future, and then we'll leave you guys maybe with some ideas about what somebody else could do with this as well, some use case examples as well. So let's jump in. First, kind of want to level set, because I don't think everybody is thinking about on-demand networking maybe the way that we are, and network as a service, so the as a service term, but we think about that a lot in the compute and other places. We're thinking about it from a Lumen perspective in the network. And so for many, many, many years now, we've been partnered up with AWS and Direct Connect, and we have provided waves, Ethernet, and IPVPN services for our customers from their data centers, their branch offices, their headquarters, their some other places as well, and into AWS. And I want you to think about when we talk about, I say we've done this in the past, you'd call your Lumen salesperson, we'd talk about it, we'd give you a quote. I'm slowing down because this is how the process of, in the past it would work, right? It would be, we'll give you a quote, we'll get an order, you sign it, and sometime later, weeks, maybe even a month later, we give you a service, right? That connected you from that location into the cloud, right? And what we're really talking about in on-demand networking, we'll get into in a little bit, is a way to get that faster and a few differences. I do want to call out one thing here as well. The difference between what we're talking about is private networking in this case, where you've bought a wave, you've bought Ethernet, or you've bought IPVPN over a private IP and PLS backbone for IPVPN and Ethernet, or a wave, literally a color of light across our optical platform. So it's a private network. We also support internet. A lot of the use cases can be done over the internet, but there are some use cases where a private network may make more sense for security and some other things that I'll touch on as well. But internet is an option, but this kind of level set to your mind from now on that we're going to talk about private networking and how to connect from a private networking space. So to kind of switch gears a little bit and think about what do we mean by on-demand networking? In on-demand networking, what we're doing is Lumen's actually going out and has a lot of connections that we're putting in place. The connection to AWS, for example, is a connection that we host. We put it in. It's called a hosted connection. We have lots of connectivity into Major League Baseball, NFL stadiums that we use for Fox and all the other broadcasters globally as well. And so those are connections that Fox pays us to use them on a weekend basis, but we pay to put that connectivity in. We support and put that in. So there are a number of these connections in the on-demand platform that are hosted. You guys, as a customer, wouldn't have to tell us, hook up to this site or to some major site like that. If it's your customer location, we're probably not going to put a customer location on site on our dime. We'll talk to you about that. But the point is that there's a number of locations around our network where we're going to put in a large amount of bandwidth and allow people to use it on demand. On demand meaning we're going to let you turn it up in a self-serve portal for an hour and turn it down, or 2 hours, or a week, or whatever you need for your use case, your application. We're going to allow you to establish what that bandwidth is. Maybe you need 50 meg for a small set of IoT devices that are going to come back across that. Maybe you need a large bandwidth setup like we used for Fox and AWS in the example that we're going to show you, where you set up 5 gig, 10 gig, or more bandwidth for a couple hours. In this case, we did a baseball game, 6-7 hours, probably max if there's extra innings average kind of 4. So you'll see that the path here is lots of places that are physically connected, but we're going to allow customers to do on-demand logical connections. We're going to let you set up Ethernet or connect to the cloud with your IP VPN network. So you may have 10, 20, 30, 40 sites as a major company on a VPN network, private VPN network, and maybe you need AWS Cloud for a couple hours, a couple days, or maybe you need it every Saturday for a few hours because you've got a workload. So we're going to let you turn that on and manage your cost and manage the bandwidth across it. And so, to kind of jump a little bit forward too, why would you want to do this? Kind of working around this horn, private networks are a known network path. Internet's a, globally big, ubiquitous platform, allows you to connect to a lot of things. One of the advantages of doing this over private networks is you kind of know the latency. It actually might be higher or slightly lower than the internet path that you use, but it's consistent, right? It's going to be the same speed and the same latency as you go around it. So it's a known network path when we set it up, and it has known failure paths as well, like predetermined failure paths. So it fails over quickly when it does fail. Hosted connections. So again, I kind of hit on this already a little bit. Hosted connections are something where we, Lumen, are taking on the expense of setting up to venues, data centers, cloud service providers. We're maintaining that capacity. We don't expect you guys to want to put in 100 gig pipes like we're doing, multiple 100 gig pipes. We want you guys to take the bandwidth for the time you need and use that connectivity. So again, when this is on demand, there's lots of capacity into the cloud service providers or others that we've got out there and available for use literally within minutes of provisioning time. So you log into a self-serve portal, pick your A and Z site, say connect, 2 to 5 minutes at the most. That connection's in place. We'll show you a little bit of that portal. You accept it in the AWS portal, and it's all connected. It's secure. Look, the internet is an important part of the whole cloud service business. We just want to make sure people understand that. You can do a lot of security, a lot of overlay, a lot of SD-WAN. Lumen as a company supports all of that as well. But we have a secure MPLS backbone that's very large and very global and been there for a long time. So you kind of get an inherent nature of security. You still need to put security on top of it at the end, but it's a secure backbone. Customer sites, we can connect to a lot of customer sites. I'll show you some building counts in a little bit as well. But our network's well connected. We can get to the customer sites, so they're a part of this vision. It's predictable quality, kind of back to that known network path. I don't want to spend too much time on this. I think the last bullet, though, on here, kind of around the horn, is an important one, right? We're trying to change the telecom model. We no longer want you to buy 1 year, 2 year, 3 year commits on telecom bandwidth from your customer side or your data center into the cloud service provider. We want to match what the cloud service providers do in giving you the compute for an hour, up the memory, a new different charge, right? So charging by bandwidth, charging by the hour, and there's zero commit in our model. So when you use our on-demand networking product, basically the minimum is 1 hour, not a 1 year, 2 year, 3 year commit. So to talk about just how big is this and what do we do as Lumen, we've got 160,000 buildings on our network that we can connect to. That's the customer sides of this. There's 2,200 third-party data centers. These are all the data centers that you guys use and buy co-location and other services from. So where you have your assets today and might be moving to the cloud, we're connected there. We have shared hosted capacity into those facilities, and that's where we want you guys to leverage. Like if you're trying to get out of a data center and move that workload up to a cloud, if you're trying to get from the cloud to that data center temporarily, moving between data centers, you can use this connectivity for the time that you need it on demand at an hourly charge and turn it down and cut your cost, right, at the end of it. And speeds and feeds are important. That's the last part, right? We go as low as like 50 meg in this dynamic world, but we're really trying to bump it up. We know you guys have a lot of workloads. There's a lot of content you're just trying to move because it was data you aggregated or that you want to move fast to an AWS storage facility or whatever. So, on our Ethernet platforms, we're up to about 30 gig in capacity that we can enable today. Some of that is actually bound by the cloud service providers as much as it is us, but we're trying to figure out how do we get faster and faster speeds. What it means for you guys isn't so much, I want you to think about it as like, how fast do you want to move your workload versus the cost that you would pay. You could get a lower speed, move petabytes of data up, it might take you a few weeks. If we can get you up in the 100 gig or greater ranges, and you can move it faster, maybe it enables a work use case that allows you to get to the data faster or does something different for your business. We're trying to figure that part out and help you guys do that as well. So I'm going to jump in a little bit to what we set up, and then I'll turn it over to Brad to talk about it a bunch more. But so for the media and entertainment use case that we did, like I said, we have lots of connectivity into baseball stadiums. Our Vivix brand's been around since I started with the company in 2000. I think it was back there in the late 80s that it started, right? We have lots of fiber connectivity into stadiums, and I think it was Evan that called and said, hey, would you help us out with a use case that we want to set up and go do, where we're going to connect from the St. Louis Cardinals baseball stadium back up into the cloud, we're going to do this production. Sure, let's figure it out. So it's a pretty simple view in this drawing, right? All we really did was took our Lumen hosted connection, that connection that they wouldn't have had to buy, we have it there already. We went into the portal, which is this screen. We put in the A and the Z endpoints, which we'll show you what those are, but basically A endpoint is the St. Louis Cardinals Stadium, Z endpoint's the cloud, AWS Cloud. And we said, at this bandwidth, connect. And if you could see, and I know it's pretty small, on the portal, basically it's showing you, yes, that those sites are available, you pick the A's and Z's, you put your AWS account number, we'll talk about why that's important in here in a second. And Evan, you forgot to tell me to build the slide. I told you to remind me of that, but there's connections in minutes. And what you'd see though in here is as you build through this and you choose your AWS account, you can actually then click buy. And you can say, I want to do it at this bandwidth. You're going to see the pricing in there at the moment in time and submit. And within a few minutes, this connection is going to get made across the Lumen network. And let's see if it flips over. This is the AWS console side of it.
Next.
And so the back half of this is you got to go into AWS's.
You have to build again.
Oh, come on, Evan. Did I go too far?
No, you're good.
You're good? I'm good. All right, so the last step to making this connection after a few minutes is to go into AWS's portal and say, accept. And once you've accepted, you've got a connection from, in this case, Busch Stadium, back to the AWS Cloud at a couple locations in this case. And they were connected and ready to take the feeds from the game and do the production that I'll let Brad talk about next. And by the way, just for one other thing, we have some time at the end. We might have time for questions, might not, but happy to take some if you guys have some at the end.
Hey, so we've been actual kind of on-demand customers with Lumen since the early 2000s from that side. In essence, when the first portal came open, we were booking video feeds, doing that kind of stuff on a regular basis. As we entered into the late 2010s here, we started booking Ethernet and Ethernet virtual private line circuits and things like that. So from this side, we're really excited about the AWS Direct Connect. We actually used this during the World Series back in 2020 for the first time when we had to get into the AWS Cloud to do a project with Samsung and some other sales partners. So a lot of this that exists is something that has been out there and been utilized in a lot of places where this kind of connectivity exists. But for a little bit about us, obviously, and the things that we do, you've probably watched us. I'm sure you've all watched the World Cup in the last couple of days from that side. But from this side, obviously we produce an absolute tonnage of programming across multiple networks, including FS1, FS2, the Fox Sports Network, and also the Big Ten Network as part of our portfolio here in the US from that side. And when we talk about interconnectivity and pushing the limits of what we're doing, we're really talking about doing things in 4K HDR at the highest bandwidth and the highest quality levels to do so. And in doing that, it continues to push what we did. And so while we looked at this POC and working with Evan and Ryan, we weren't just talking about doing this in kind of a normal HD format. We said, no, we're going to do this in 1080p and make sure that we're getting the best quality across the networks that we do from that side. But just to kind of wrap your heads around what it is that we had to come out and produce. And so you can kind of see up here on the board, which is the amount of people it takes and the amount of equipment it takes to do some of our shows. So, way on the far right there, you see the game. And that game is pretty accurate, roughly to what we did for baseball. That's a college basketball game, that's a regular season Major League Baseball game, things like that. But you can see the numbers continue to scroll upwards as we get into that. The Super Bowl this year will be larger than 390 on site. It's more like in the 600s of people. The camera count's well over 100. The World Cup is the same kind of thing. The World Cup's 550 people over in Doha, Qatar right now actually producing for us, along with another 150 in the US. So it's a lot of people and it's a lot of things, as you can see. And really the middle line there that we want to look at as we start talking about things that are kind of really truly tied to the cloud as much as humanly possible is that replay line. Replay are all the highlights that you see during the game. The slow motions of people breaking their legs, those are always kind of the best ones. But also too, of whether or not a foot's inbound or outbounds, whether a ball, is fair or foul. All those type of things are really important to that. And so replay is one of those things that really the cloud was built for. Because the beauty of it being is that we want this to be elastic. We want the ability to add things very quickly and on demand as things are happening, which is not something that you can normally do with a 53-foot tractor trailer that's running down the road. It means shipping stuff in, it means finding equipment that may or may not exist versus just spinning something up in SaaS from that side. So this is part of what we started to look at, and as we were talking with Evan and the team at AWS M&E, we really figured out that there was another approach and there was a next level that we really could kind of get to. And so this is where we come into, kind of designing this setup in that we said, okay, time out, hold on. What if we just did the whole thing in the cloud? And so we took the baseball game it was a 9-camera baseball game, plus a couple of replay sources, plus a couple of graphic sources, things like that, and put them together and said, okay, we could do this and we could put everybody in Los Angeles at our network center just kind of like we do with our normal home run production setup, which is taking camera feeds, shipping them back to our Los Angeles, our Charlotte, or our Chicago network centers, producing a game and putting it on the air. Something that we do well over 300 times a year. It's something we have 2 games tonight on. It's nothing that's kind of out of the realm for us. We get a Lumen direct connection from a stadium. It goes back to one of the 3 network centers. It gets produced. It gets shipped down to Tempe, which is our master distribution center, and it gets sent out to the world for all of you to watch. But we said, well, time out. What if the people weren't in one spot? What if they were at their home? So the A1, the audio mixer, the replay operator, the technical director, the graphics people, and the scorebug people, we all put them in their homes and said, hey, by the way, go sit there, run the equipment that's going to sit in the cloud inside AWS East, and let's see what happens. And let's really run through this paces. So we linked in with a number of great partners, including Grass Valley for the video switcher and the audio console, VizRT and Ventus for our graphics and scorebug, and Simply Live for our replay, along with Telos for our intercom systems and things like that, and locked it all together with a whole lot of help from the AWS M&E team, and made a simulcast production happen. So we had a full show on site in St. Louis at Busch Stadium. They produced the show, and all of these people you see listed on the screen were at their homes cutting alongside of the main show. So this show didn't go to air, and we weren't really sure if it could have. We were shocked to know that it could have, and Evan will run through that as we kind of continue on to make this stuff happen. But you can see what we're able to do. So the producer and director are in Busch Stadium calling the show, and all of these people are following along technically to make a production happen from that side, and that's where we're at.
Thanks, Brad. So when we first contacted Ryan's team about the idea of on-demand networking from a stadium, I had no idea how easy it was going to be. I really mean that. I thought, because I'm used to the whole order a direct connect, and then you send them the order for the A location, the Z location, you wait a month or 2, and then eventually it gets turned on. But what happened was totally different than that. What happened was I called and I said, hey, what would you think about doing a baseball game from Busch Stadium? I need 2 5-gig circuits to US East, and I want them to take diverse paths so that if one goes down, we still have the other one. And the answer I got was like, yeah, sure, I'll turn it on now. And it was literally, no, I'm serious, like, It was amazing. I'm impressed. From the time we had the idea and called Lumen to the time that we had 10 gig into US East 1 was 4 days. And most of the 4 days was just scheduling a meeting to talk about it, to be honest. We turned it up, and it showed up in the console of the POC account, and we were ready to go. The next thing we did was we said, okay, well, if we're really doing this in the cloud, what's the minimum footprint that we need on-prem? Like if you were to say, what if there's no truck? What does something very small look like so that the most as possible could be in the cloud? And we came up with a 10RU case that essentially had redundant JPEG XS encoders, which is a very low latency, high quality codec, a pair of Juniper switches, and a clock, and some power gear. And this is what it ended up looking like. This was the entire kit that we shipped to the stadium. And really the reason that there's 2 of everything is just for redundancy. If you think of what you really need here, you could probably have half of this stuff. But for television production, you always want to have redundancy because something's probably going to fail. We got actually really lucky. Nothing on this side failed when we did the show. And so from here, what we did was, if you see the BNC patch panel somewhere in the middle of the rack here, that's where the camera is plugged into. And originally, we were going to take 8 cameras, like what Brad was talking about. And we ended up having more capacity than that. And when we polled the crew, like the replay operator and the technical director who were sitting in their homes, they kept asking for more. So we ended up actually with 18 feeds that we were able to bring back over the 5 gig lines. And this is what we ended up building in the cloud. And I'll just run through this quickly. On the left-hand side, you have the kit that we sent to the stadium. We have 2 hosted VIFs, courtesy of Lumen, thank you. And we sent the JPEG XS feeds via both paths simultaneously. So actually, in television, what you would normally do here is you have 2 separate BGP sessions. It's not in a failover configuration because you actually want it to be active-active. That way, if one fails, there's a seamless visual transition to the other circuit. So we had 2 separate BGP sessions that were hosted VIFs, and they came up. We pointed those streams from the kit into Media Connect, which merged those 2 streams and output the individual camera feeds into the rest of the system. The rest of the system amounted to getting all those feeds into a virtual production switcher. Like Brad mentioned, we use Grass Valley's AMP system for that. That's the device that actually changes the angles of the cameras. Then you have Simply Live for the replay. So we had a replay operator in New Jersey that was doing those slow motion. Telus for the intercom. And Viz Vector we used for the side-by-sides. And I'll show you the side-by-side in a minute. What we ended up with was essentially a mosaic that looked like this coming into the cloud. We had a multi-viewer, so we also sent all of the individual feeds into a mosaic system that created this output so we could see all the feeds coming at once. So what you see here is cameras 1 through 8 in the first 2 rows, and then the other, I'd say, aux feeds coming on the bottom 2 rows. If you look in the 3rd row all the way on the right, that's the program feed that the truck was creating. And I'll play this for you now, and you can kind of hopefully follow along with what the director was calling, and you can see the shots change here. So this is where we need the audio for the clip, and hopefully it doesn't blow up the speakers.
Rolex dissolves A-track.
Okay, so what you might sort of hear is the director coming out of that speaker asking for the shots.
When his foot hits the base, freeze it.
Right, so.
Open Kenny.
Thank you.
Font 2. Add font 2. Stay with him tight.
And in the end, we ended up with a show that looked like this. I'll just continue on. This one has audio too.
Hitter with fewer RBIs.
It's going to have great music with it.
Yeah, I know. Can people actually hear this or no?
Ready to take 2.
Is there a way to like turn this way up without the music?
Goldschmidt. Ready 3. Take 3.
Surely you have different faders.
Take 8.
This is a new way to watch baseball.
Sure.
It's a calmer way.
It is calm.
Ready to replay to green.
Yeah.
Pick the green, track green. Roll. It's about to dissolve Y slow. It's ready to dissolve X slow. Roll X dissolve fade track. Nice and slow at the tail end of it. Ready to dissolve Y. His foot hits the base, freeze it.
And this is actually the show that got produced in the cloud. So if you see like the bottom right corner where the score bug is, that was being generated from a Ventus graphic system. And that other one where it says Ken Rosenthal was being created from a VizRT system. There's 2 graphics machines in Fox Productions. And a home run. Look at that. Okay.
Ready 4, take 4, ready 2, take 2, ready 1, take 1.
So you get the idea. I think this is why Brad said this was watchable. Like this could have gone to air as the backup. And then the last thing I'll show you is a side-by-side comparison of the same clip, showing the AWS created program and the actual truck program. And what we were looking for here, we created the side-by-side because we were looking for discrepancies to see how close the 2 productions were.
Well, that's 2 different subjects, though, right?
Correct.
For sure. Correct.
Skimming softly on the ground. Grissom a long way to get to it. Unloads quickly. And Goldschmidt legs it out.
Told you the big guy can run.
So if you're a video ninja and you like look really close at the full resolution version of this, maybe you can see a little bit of difference. But for the purpose of it being on television after it gets compressed a few times, by the time it would get to your house, there's no difference in these productions. These slow motion replays were taken from the Simply Live system, not from the truck.
Timing steps are perfect.
The replay operator had all 8 angles, so he was able to cut clips from all of those angles.
Traditional Triple Crown also leads in all three slash line categories.
So we were pretty excited about this, that this worked.
As well.
Brad sent me a text and said, holy crap, this works.
Arenado! Blast off left field! Gone! Home run! It's a 1-run game!
Oh. Yeah. Home run's always exciting. I think the Cardinals won this game.
I believe they did.
Yeah.
Is that for us at Fox, it was really interesting to see that in the end, when you're watching that dual screen of both the AWS content, AWS produced content and the regular show, is that it came down to people timing differences. It wasn't a latency problem. It wasn't a tracking problem. It wasn't a communication problem. It really just came down to the feel of, hearing the commands, getting ready, punching, doing the things you need to do, both audio and video, in order to do it. So that's, for us, really proved that there was a much better kind of long-term approach to what we're doing here than kind of what we expected. To be honest, we thought that we'd have a lot of latency. We thought that we'd have other technical challenges inside of it that really never appeared during the show. And so obviously, we're all kind of at the ground level of this architecture and this setup. But from that standpoint, it really felt very natural to all the operators who do this on a regular basis.
Thank you. Yeah, on latency, let me add that, because that's what this slide is all about. So one of the things we wanted to do was make sure that we weren't adding any latency, ideally, to what the program would have been coming out of the truck, because sports is all about, one of the things sports is about is low latency. People want to watch it as close to the time that it actually happened. So one of the things you want to do is make sure that the latency is as close to possible as what's normal for a production. And the second piece of latency actually is how operable the equipment is. So for those not familiar with live TV production, you're using custom control surfaces to control your switchers or your audio mixers or whatnot, and you want it to feel immediate, like when you hit a button to have a visual response right away. For those not in television, I usually compare this to playing a video game. Like video game streaming in the cloud is actually a new thing as well because of the latency. So you want your control surface to be as close to be able to give you a visual response as possible, ideally less than 100 milliseconds. If it's more than that, it becomes unplayable essentially. So we had good feedback from the operators here. They said that the latency between hitting a button and receiving something back is about 4 frames of video. So at 60 frames a second, that's about 65 milliseconds or so. That's to like the super trained eye. These people I mean, these people who are doing the show have been doing this a long time. They're the best in the business. To you and I, we probably wouldn't have noticed any latency at all.
I think it's interesting because, like we talked about earlier, right? The video feeds were going over a private network and had consistent latency. But that is actually coming from an operator using their home internet connection back through into the cloud to push the button, right? And so when you, like I said, when you do this, the fiber optic latency across all those platforms, right? Speed of light is the speed of light, right? It is what it is across all those platforms. You have to think about it when you're designing this a little bit to make it work for your application.
Yeah.
But it's amazing, we didn't do a whole lot, or you guys didn't, right? More so than us. Lumen kind of set it up, but you guys were able to use it kind of out of the box. We didn't tweak it. We didn't go think about where that person was at coming back in over the public internet, right? It's an important part that it just worked kind of out of the box.
One thing we did do was that we measured the latency between the two direct connect paths.
Correct.
So that we knew how much buffer to add in media connect. So what you have to do when you're merging streams, like I was talking about before, is offset the earlier one by the skew in the latency so that both streams line up once they hit the frame buffer. So we measured that. It was only a frame difference. That was it.
Right.
The control data is really low. I mean, it's just little control chatter, like kilobits per second. It's nothing big. The video is the big stuff. Most of the control services are just fancy mouses at this point, for lack of a better term. Anyway, I guess the headline of this one is in the bottom right corner. I went to Tempe, Arizona, where Fox has their channel control facility, and I compared what was coming from the truck versus what was coming back from the AWS Cloud to their video router, and the difference there was 5 frames. And then we kind of tried to be perfectionists and says, where can we take out 5 frames? So we have a few ideas about that, but 5 frames is pretty good. It's better than what we thought it would be. Anything else to add about this? Okay, let me hand it back over to Brad for a moment to talk through the control surfaces and what people saw at home.
Sure. For those of you who maybe don't know the terms, technical director is the person who actually changes all the cameras, inserts all the graphics, makes the video work on the broadcast side. So sitting in front of our technical director at his house with his nice Emmy on his speaker up on the top left side is a Corona panel from Grass Valley. So what we're able to do is that the AWS team also provided VPN connections to these people's homes. The monitors you see are all WebRTC screens off of small appliance computers, along with then a VPN connection to the Grass Valley AMP Cayenne frame back in the cloud. And that panel is actually the hardware panel that they would use if they had a real hardware frame next to them in a mobile unit. From that side, it's a smaller panel than we might use on a normal basis, but still big enough to do this show from that side. So that was his panel there. You also see some other devices on the side. There's a stream deck that helped control his intercom panel, which was hosted on a computer. And then he had 2 of his own screens. So those 2 multi-viewers were just for Paul, who was our technical director, in order to see things. So on the monitor straight ahead of him, you see preview on the left, program on the right, and then his cameras were up above. And then on the right-hand side, you have a lot of his replay devices. You have some extra graphics channels, things like that, things that he doesn't look at full-time in order to do that. But this is sitting on his house. He happened to have fiber 1 gig internet at his house in Raleigh, North Carolina. So he was in one of those places that had all the speed you could ever possibly need.
Can I add one thing to that?
Sure. I
What
worked the back button.
What we sent, nice,
Yeah.
the back button. What we sent was an Intel NUC computer. It was about this big, and it had 2 DVI or HDMI outputs that connected to those 2 screens. So we sent 2 screens and a computer this big, and that was it. And he was able to do this. And I was looking at the truck behind the TD at the same time, because for the first game I went to the truck. This is pretty much exactly what they have there. They got 2 screens with the multi-viewers like that, and a station like this. And what you see in a truck is multiple stations that look like this repeated for every operator. So we essentially just broke the whole thing apart and gave him his part of the truck. That's all, thanks.
Yeah. No, now as you'll see, this is the A1, the audio operator. So this is the person that mixes all the sound, the announcers, the effects mics, all the audio playbacks and things like that back into the broadcast. he decided to sit on his porch with only a cable internet connection, so and not necessarily one of the faster ones you'll ever see in your life from that side. But again, he has his 2 monitors on the side. In front of him is his control surface and console, and then down below is an actual fadered mixer console for him to use. So this is still the Grass Valley AMP platform that he's running off of, and then far on the left, he's got his own little audio playback device as well from that side called Spot On, which actually lived in the, or actually I should say Spot On's on the right, and that lives in the cloud as well. So it was one of those devices where there were 2 products in this that we helped actually migrate into the cloud. The second one being the Spot On that you see here, and the first one being the Ventus Fox Box, which is a proprietary app built by Fox Sports in order to put the bug box in. Obviously, some of you may be old enough to remember we were the first people to put in constant score in the NFL back in '96, or '94 from that side. So that's the audio person setup. And then our replay operator had the same kind of setups that are there. And you can see Paul there operating his replay setup again on a cable modem up in the hills of New Jersey. There are hills in New Jersey. It's not just Newark from that side. So from that bit. So again, he's got a control surface that's proprietary to the Simply Live device that actually controls it. But again, on his right side was actually a touch screen he could do things with, along with regular keyboard and mouse, where he enters in all the names of the clips and those kind of things as he goes forward throughout the day. Our last 2 people are the Viz Graphics operator and the Foxbox operator from that side, and you can see they're both running off of, you can't see the laptop on the Viz Graphics person on the side, but again, an Intel NUC running that, and a second one for the screens. And then the Foxbox operator actually ran everything off of his laptop from that side, so and some of his screens. So really had a lot that was going on there in order to make them work, but both of them working from their homes in Los Angeles Metro. So from that side, and then Evan can guide you through
Sure.
the AWS side of the world.
Yeah, so lastly, we had an engineering station that one of our guys, Alex from ProServe, set up, and he was in his home as well, just make sure everything was going well, and he would have seen stuff go down. He would have been able to fix it right away. We actually did, in the first game, we actually did have an issue where we had an issue with an NVIDIA driver going down and causing a crash, so Alex fixed that in the bottom of the first inning, and then the rest of the game went well. And so that was our engineering station. The next 3 pictures here in that, I guess the L shape, is us on-prem. So we had the kit there. If you look closely, you see that the kit is so small that it fits under one of the hoods of the actual truck that was running. Like we got to sit under that, that little thing in 100-degree weather because this was the middle of the summer. And so we essentially just set up some monitors on top of the mobile kit that we sent there and did some local engineering from there. But for the most part, all we did on site was connect the kit to the Lumen switches and say we're good to go. The next thing I want to share with you is how much this cost. So, obviously the prospect of flying everybody around and sending a truck and producing games the way they've always been done is expensive, but it's worth it because sports has a lot of great viewership. But in the cloud, the entire cloud budget came out to about $4,600 over a 24-hour period. So we left this running for a 24-hour period because it was a POC. But if you were to think about a baseball game, the production day was 12 hours. So people check into their stations usually 12 hours before the end of the game and work a 12-hour day. And so you can just think that it would be half that. It's about $2,300 public pricing for all the cloud infrastructure. That doesn't include software licenses from the software vendors. It doesn't include the specialty hardware that we looked at. And it actually doesn't include the on-demand networking. So this would be the AWS bill at the end of a show. This is another way to look at it by instance type. So we used, the largest instance type we used was a G5.48XL. That was used for the switching. So the camera switches with Grass Valley AMP, that thing is doing the switching, so it needs a lot of frame buffer, it needs a lot of network, and it needs the ability to key graphics over. So all of those graphic overlays were being done within the AMP system, so it needs that big instance. So what's next for live TV production in the cloud? One thing was, this was all done manually for the most part right now. As you know, the first thing I did was call Ryan, so we're trying to make real APIs instead of phone call APIs. I like calling Ryan, but it would be better if I didn't have to, no offense.
Yeah, true.
And so we want people to be able to do this on their own and be able to deploy whatever they want, when they want, with on-demand networking and cloud resources. The second is highly available design patterns. So we ran the POC in one availability zone. Had we lost that AZ, we would have been scrambling. And so we need to find high availability systems, maybe 2 AZs, maybe for a big show, maybe you'd want to go multi-region even. Those are all possible today. We just got to work out what the operational patterns look like. So for example, if you have your TD switching a show, what's that panel controlling? If you have 3 switching instances because of redundancy, that's the kind of thing we have to work out for high availability. I think now when that happens, they just switch to another panel, right? Like if you have a panel controlling this switcher and you need another one, you just go over here.
Yeah.
For big shows, you roll multiple trucks. Even.
Correct.
Yeah, so we need to work that out. Maybe working it out just means that if it only costs $2,500 to do it, you just have 2 of them like we always did. That's the easiest way. Higher video quality, Brad mentioned that. That means, what are we looking at? Bigger raster sizes, 4K, 8K, HDR. This show that we did was in 8-bit because some of the codecs only supported 8-bit right now. But if you use an SDI wire, those are 10-bit 422, so higher bit depth. I guess there's nothing limiting it to 10-bit anymore either. I guess for graphics, sometimes people want to go above that. So I'd like to see some of that happen. Greater technology availability. What I meant by that was all of the partner technology that we talked about today is pretty much in its infancy when it comes to cloud. Everybody's interested in migrating to the cloud, but we're very much in this POC experimentation phase, and new stuff is coming out all the time. For example, multi-phase replay. So we just did regular 60 frames per second replay, but actual super slow-mo replay cameras, even in a baseball game, are running at like 300 or 360 frames per second, and those are transmitted via multiple phases. So that would be, that'd be a nice area for improvement, I think. And just the maturity of the whole ecosystem coming to be. The next one I'm excited about is lower carbon footprint. So everybody has sustainability goals now. AWS has a ton of sustainability goals. I'm sure Fox does too now. And so the ability to not roll as many trucks or not fly as many people and create a more sustainable way of creating content is interesting to a lot of people. And lastly, more content production capacity. So what this means is shows that may not have crossed the threshold into viable for commercial reasons, like if they're a tier 3 sporting event, something that somebody has the rights to, but may not be able to afford to do a whole shoot, maybe for $2,500 they can afford it. So I think we'll see more content become available. Is there anything you'd like to add?
No, I think you grasped it.
Okay. Let me pass it back over to Ryan now about some other ideas.
I'd say too, the one thing that catches me, one is it's always the audio guy that works on his porch. Let's be clear, right?
That was at his beach house.
Yeah,
He wanted to work from his
exactly.
beach house.
We were kind of laughing when we heard that initially, so I think that's funny. But two, I think, go back to the beginning of what these guys did here, and I think Lumen's participated in a number of remote production stuff in the past, but we always took a $20 million truck and moved it to a site, and we took cameras back to it. We didn't change anything. We just basically made it harder to get the network video feeds from the cameras to whatever the gear was. And the difference in this is that software piece, right? We lit up a bunch of compute, generic compute in a lot of ways, in every way almost, and put software on it. And tomorrow, that same hardware that ran the production switcher or the audio guy's equipment back in the cloud could do the stuff that we're going to talk about next, which is, what are the other things that you guys could use on-demand networking for, so lighten up the network, and obviously the compute as a service, or the AWS Cloud as your service partner. And I think that's interesting. So we wanted to shift a little bit. We got some time too. If there's questions, we'll run through. There's 3 or 4 of these kinds of slides that more just to get you to think about, okay, I don't know what industry all of you guys are in, but I'd like to have a conversation with you if it made sense, or get you teed up to the right Lumen person or the right person with Evan, If you're media, in content play, we'll get you with Brad, but have a conversation about what's your use case. How could you use on-demand networking to hopefully cut your networking cost, but use it more effectively? How are you, doing this into the cloud? Retail and hospitality is one that we talk a lot about. There's a lot of surveillances and cameras and other things that come back. This isn't one I was going to spend a lot of time on, but I just kind of wanted to throw up there that, these are the use cases that Lumen's been looking at and try to figure out how do we work with our partners to figure out, again, go back to those hosted locations, right? Where can we light up bandwidth at our own cost that helps you share capacity with partners, competitors maybe, or other just locations you need. Maybe it's hospitals, or whatever it might be. But retail and hospitality is one of the bigger industries that we're after. The utility grid, we talked a lot about, and Evan kind of mentioned it, the eco footprint, the carbon footprint of this aspect, right? And what we're doing here. But we're also doing this for utility companies where they're taking data and sensors about how much power is being put back into the grid from solar or wind or whatever it might be, and all the sensor data. And they're trying to figure out the amount of data at the time of day can vary, right? If it's a hot season or by seasonalities as well. And so we want people to think about the network as a dynamic asset too. Let's spin it down. You're not using it right now. Let's go ahead and spin it down and save your cost for your company. So some of the utility use cases are about trying to be more effective with utility and getting the data back to run the plant, but also cutting your cost to get the data back is part of what we're after and what we're out there for. I kind of started to mention healthcare. I think it's another one. There's a lot of medical stuff out there. Obviously remote medicine and remote surgery is a huge thing, and some of the video stuff that we've done to telemedicine stuff is important for surgeries. This is also about just taking healthcare data and getting it back from medical devices you might be wearing to your doctor or other places. And so, there's a lot of use cases in the healthcare industry that I think could be unique that we've looked at as well. And so last slide, so if you do have any questions, like I said, I think we'll be open to questions. We got maybe 10 minutes or so of time at the end of this, and there's only one more slide, which is sort of a similar use case, but I thought it was kind of an interesting one to throw in here as well, which is, studio sessions. Not everybody has to be in the same location. We saw some of this during the pandemic with remote concerts and people doing stuff across the internet backbone and others. And when you look at some of the gear that these guys were pulling from the truck and giving that, they're not huge panels. The cost isn't in that physical gear as much as it is in the overall ability that it's in the truck with all the software wrapping around it, right? If you could start to think about how to collaborate with people across the world over a private backbone to bring them together and bring them to the right place with that gear in it, right? These are the types of applications that Lumen's looking for, and I think AWS is looking for. Obviously, media and entertainment's got their own use cases, but we're looking to figure out a couple of things, I think, along with AWS, which is where should we connect? Where are those hosted connections that we bring to the table, and what bandwidth do you need, and what kind of latency and parameters around some of that redundancy do we have to build to provide the the right solution for the right use case that others have. So that's, I think, a wrap on the content that we've got.